Okay, so you should be familiar with how to open up Insight, run Insight. The data that you're looking for, import data, is going to be on student drive, maths, stats, 13 stats, and then it's going to be Insight data sets. It's going a bit slow for some reason. Bivariate. And today we're going to look at sports data. Notice that there's an Excel and a CSV file. You want the CSV file. You'll quickly find out that if you click Excel it won't work. And open. Okay, so you can click View Variables. Now a lot of these acronyms you won't necessarily recognise unless you study sport, but you're welcome, or before the assessment you'll go and Google. We'll give you the variables and you can do like you did for time series, go and Google them and find out what they mean. But as a comparison and to determine which two graphs or which two variables to look at, if you highlight them all, actually sorry, if you click Advanced and click Scatter Plot Matrix, highlight all the variables, hold down Shift and click Plot. It's going to be hard to see from where you're sitting, but these are all the combinations of independent and dependent variables, or X and Y variables. And that's what you're going to do very first off, and you're going to go looking for, to start off with, ones that look like a linear relationship. Okay, if I point to them with the mouse, that one there is fairly linear. These ones are linear. These ones are linear. So if I just choose there's one with weight in it, which is WT. Where's that? Weight and LBM, lean body mass. Now what that is I had to Google it myself. It is, anyone know? Lean body mass? It's the weight of your bones, internal organs, blood, and everything apart from your body fat.
What about muscles?
And muscles, but it just doesn't include your body fat. And that's why you can tell that there would be a relationship between weight, it's kind of like weight and weight, but lean body mass. Used in sports for some reason. Okay, so cancel out of that, and I'm going to plot, and it's a bit different from your time series one, lean body mass as one variable, and so you just noticed I clicked and dragged there, and weight, which is down the bottom. Okay, and then you can go how do I plot it? View data set? No. What I'm doing now is I'm adding a line or a curve. So click OK, click blue, click linear rather. You can change the colour line. I wonder if this is going to work. No, why is it not working? If I click inference. No, I don't want inference. No, I don't want summary. It's supposed to come up on this page here. Here it is. That's why it didn't come up, because I had a window behind it, and I've actually already done this. So LMB versus, oh gosh, I've got residual there. Put weight back into here. What's wrong there?
Too accurate.
It's too accurate. It's impossible. It's like I've got weight versus weight. I think if I close this one down. No, I don't want that. I want LMB there. That's it. That's what I want. Okay, weight versus lean body mass. And at the same time, I've actually just added a model, and it happened to be a linear one. If I want to change it to a curve, add to plot, add trend curves, click OK, and the other two I can add is a quadratic and a cubic, or a cubic. Okay, they're just different models, and not for achieved, but later we'll learn how to analyze which one is more appropriate, the quadratic, the cubic, or the linear model. Okay, close that down. You'll note from yesterday's graphs there was an equation and an R value. You can get that by clicking on Get Summary. Okay, and this is the equation. It was like that on the graph I showed you yesterday. On the top right hand corner it had an equation, and it also has the correlation coefficient, 0.93. Is that a strong, weak, or moderate relationship? Very strong. Okay. Okay, and that really, you need to crop this and put that onto write it onto the Word document. You need that correlation coefficient, you need that equation.
To get achieved.
Yep. And you need that graph, all for achieved.